stoichiometry means is looking at a balanced chemical equation, because that is a powerful tool. It will give us the opportunity to make quantitative statements and predictions about relative masses of two substances that participate in a chemical reaction. So for example, if we have these combustion reaction of butane, first thing we have is a reaction that we need to make sure that it's balanced, because that way we will ensure that the law of conservation of mass, it's actually true for that particular reaction. Okay, in terms of the total number of atoms in both sides, reactants and products, and the total mass of both reactants and products being equal. The chemical equation gives us an insight of how the reaction works at the molecular level. This will read, or can be interpreted as 1 mole of methane reacting with 2 moles of oxygen 2 will give us 1 mole of CO2 and 2 moles of water. Because the content, the number of moles of substance are related to the actual number of particles, molecules in this case, through Avogadro's number, we can also read this 1 molecule of methane reacting with 2 molecules of oxygen will give 1 molecule of CO2 and 2 molecules of water. So that's important because now we can see that the stoichiometry studies the quantitative aspects of chemical reactions. And again, the chemical equation gives us an insight of how the reaction works at the molecular level. So that's why it's important to make this distinction between having molar relationships and mass relationships. The molar relationships are telling us something quantitative about the molecular workings or inner workings of a chemical reaction, whereas the mass relationships, the gram quantities, are giving us an idea of how the law of conservation of matter actually works for that particular reaction. Remember that if you look at the number of moles of reactants with respect to the number of moles of the products, they don't have to be the same. Moles contain the same number of particles, but the masses are going to be different depending on the actual compounds. But if we get the molar quantities into gram quantities, we're going to see that actually adding up the masses of the reactant will give us exactly the same total mass of the products. So law of conservation of matter holds. With having these molar relationships then, now we can actually use those as stoichiometric coefficients as conversion factors in order to make quantitative statements, quantitative predictions of the relationships between two relative relationships of two different compounds. For example, let's say that we start with a given amount of butane. And we want to know from that how much oxygen I'm required to use to have a full conversion of that butane and how much CO2 I'm expecting to generate from those two amounts. So the first idea is that we're going to go from moles of a substance to moles of a different substance, from butane to oxygen. That relationship between these two is given by the stoichiometric coefficients of the balanced chemical equation. So now that we look at this, the ratio, the relationship between these two, 13 to 2, is going to be factored out into what we call a stoichiometric factor. That stoichiometric factor, again, is going to be this sort of conversion factor to go from the moles of one substance to the moles of the other substance. 13 to 2 in the case of oxygen to butane. Now, if a second relationship needs to be found, in this case, for example, now butane with respect to CO2, now we're going to be looking at the molar relationship between these stoichiometric coefficients of butane and CO2, and then we're going to find out that that is going to be 8 to 2. 2 moles of butane giving off 8 moles of CO2. So now the stoichiometric factor becomes 8 moles of CO2 with respect to 2 moles of butane. Now, you will see that this stoichiometric factor is a conversion factor to go from the moles of one substance to the moles of a different substance. And the stoichiometric factors are different depending on which two components of the reaction we want to relate with one another.